Yes, I hope you all are good and doing good for the CI's exams. Guys, here today I'm going to solve the paper 1 2 mocks exam that has been asked for you in the March 2023. So most of the students ask me to help them to solve this question. The number of questions about this paper. So here I'm going to solve this whole paper for you so you can find out the difficulty level wherever you feel in the exam. Okay, the first question, that's about the topic of binomial expansion. It is given in the expansion of 1 minus 2x over a times a plus x5, where a is a non-zero constant. Show that the coefficient of x squared is 0. So it's a 3 marks question. So what to do? You guys just need to write 1 minus 2x over a times a plus x whole power 5. As we are interested to find only the coefficient of x square, and that must be 0 in order to prove it. So you can see we just need to expand this second expression, and we will expand it till we get the term x square. So by applying binomial expansion here, as you all are well aware about the rule, so it will be power 5. So 5c 0, a5, 5c1, a4, x1 plus 5c2. The difference of this is 3. So x is 2. So x2 and so on. As we get the x2, so we need to stop our further expansion. Now you can see, as we are interested to find the coefficient of x square with these two expansion, so when this this one will multiply this term, we'll get x square, and when minus 2x over a will multiply with this term, we get again x square. So rest of multiplication, we are not interested to find that multiplication. So the only we will do the selective multiplication to get the x square. So here when a will multiply, you can write terms involving x square. That will be 5c2 a3 x2, and when this will multiply the second minus 2 sorry, first we write 5c1 in times 2 by a times a4 x square. Now by using calculator we can expand this combinations. 5c2 will give you 10 a3 x square, and 5c1 will give you 5. 5 times 2 again it will be 10. a4 and a3 will be simplified to get a3 x square. So here, as we are involving the term x square, so taking x square common, we get 10 a3 minus 10 a3. This will give you 0 x square. So finally we need to show here that the coefficient of x square is 0, as it's clear from here. So we need to finish our answer. Therefore coefficient of x square is 0, so hence proved. You must show this. I hope it is clear to everyone. Okay, now the second case is about find the function. Question 2, it is the function f is such that f prime of x is 3x square minus 7 and f of 3 is equal to 5. Find f of x, and it's a 3 marks question. The important thing what I found while marking the papers, guys, you get confused about f prime x and f inverse of x. Here I'm going to write for you f prime of x mean dy by d of x, the first derivative, and f prime of x cannot be equal to f inverse of x. This is inverse function, something different, and you are well aware about it. So don't confuse this prime with f inverse. So here it means we are looking for the f of x from derivative to f of x, we need to do the reverse process, and reverse process state to get the integration of f prime f x, and is indefinite integral without limits. So d of x, here d of x as well. So f prime integration will give you, in this field I'm going to mark it, this will give you the answer in form of f of x, its derivative will be finished, and this will give you what, the separate integration, 3 goes outside, integral of x squared d of x minus 7 goes outside, and d of x. So this f of x will be 3, and x, as we have the differential of x along with it, so add 1 in the power, 2 plus 1 makes 3, and divide the same new power 3, and 7 here it goes, so we get 7x and plus constant of integration. Now we are interested to find this constant of integration c for the assigned value in the question. So after simplifying, we can write it this. As here you can see, you are given f of 3 is equal to 5. So do replace x here 3 in overall expression. Get f of 3 is equal to 3 raised to power 3 minus 7 times 3 plus c, and put it equal to 5 as it is given. So we get 27 minus 21 plus c equal to 5. So after simplifying, it comes 6 plus c equal to 5. So c is minus 1. So finally, I can finish my answer that f of x is equal to, function comes to be, to replace c here, x3 minus 7x minus 1. This is the final answer for mark 3. I hope it is clear. So let's proceed for the next question. Okay, here goes the question number 3. Question number 3. This is about the quadratics, guys. If you can understand it, most of the students get confused about this sign inverse of this whole expression. Very simply, you guys need to take this sign inverse on other side, as pi by 6 is given to you. We can write this expression. This is 4 marks question. 4x4 plus x square equal to, this inverse goes here to become sine of pi by 6. So by using calculator, keeping the values in radian, okay, because pi angle is in radian, so we will get whatever you will place, that goes to be 1 by 2. So after simplifying it, we get 4 times 2 is 8, x4 plus 2x square equal to 1, comes, bring it here to equal to 0. Now this is a form of quadratics. The topic of quadratics we have done. So if you replace, let, you can say y equal to x square. So y square will equal to x4, right? So by taking this expression will give you the quadratic expression, the quadratic equation, like 8y square plus 2y minus 1 equal to 0. Now do apply the quadratic formula, or you can do the any method, because factors not 4, yes, factors also possible here. 4 to the 8, yeah. It's up to you, you can apply any method. So by using the calculator, I can get the answer of Okay, this with this 4 plus 32, or you can do any method, right? Factorize, completing square, or use a quadratic formula. So I get two values, 1 by 4 and y equal to minus 1 by 2. And keep in mind, this is not my final answer because actually I replaced x square with y. So this is answer of y. I'm interested to get x. So now do replace values of y, that is x square equal to 1 by 4. So that gives me, taking square root on other side, either side. So I will get x is equal to plus minus 1 by 2. And here, once you will replace this y, x square is equal to negative 1 by 2. So square term never keeps its negative root. So you can say it's not a real root. So it's not a real root. So we will ignore it. So ignore. Because you know the root of negative will always give you complex number, and that is not a real root. So here we will ignore it. So our final answers are this one. I hope it is clear. Let's proceed for the question number 4. Question is about the topic of trigonometry. And if you can recall, guys, in the class, I assigned you a very simple cases, and I assigned you a few rules that will help you to find the trigonometries, the identities. Let's see here. We have to show that the equation this 4 cos theta over 10 theta plus 15 equal to 0. And we have to express this in this form, and this is 3 marks question. So first try to remove the denominator. So for this case, if you multiply each and every term with tan theta, you will see in any, you can write what here, tan theta, multiply tan theta here, multiply with tan theta with here, multiply tan theta with here, you will get, this will be cancelled out, and we get 4 cos of theta plus is 15 tan theta equal to 0 time any number is 0. Now we know the trigonometric identity, tan theta is the ratio of sine theta over cos theta. So cos theta plus 15 times, to replace tan theta with this, so it will be sine theta over cos theta, that is equal to 0. Now again we have denominator cos theta. So if you multiply again each term with cos theta, any here, if you multiply this cos theta, here you will multiply cos theta, here you multiply with cos theta. So what you will get, you can see this will go out, and 4 times cos make cos square of theta plus 15 sine theta equal to 0, because 0 multiplying number is 0, anything is 0. So here, so far we have done well. So if you can see what we are going to prove, that is all the terms are in sine trigonometric function, sine function. So here the cos square should be replaced in sine. How? By using this single identity. You should keep this in mind, always keep in mind, only sum of square of sine function and cos function, that is given to 1. So sine square theta plus cos square theta is 1. So it means cos square theta will be 1 minus sine square theta. From this identity, we can find out this one. So do replace this cos square theta with this one. So we can write 4 into 1 minus sine square theta plus 15 sine theta equal to 1. Keep one thing clear in your mind, This identity holds only when you have sine square theta plus cos square theta. The sum of the sine square function plus cos square should equal to 1. If it is sine theta plus cos theta, then it will not be 1. If it is any other power, sine cube theta plus cos cube theta, then again it will not be 1. Only it works with the square terms and it must be plus. I hope it is clear. Now expand it. 4 minus 4 sine square theta plus 15 sine theta equal to 0. As all the terms what we required, we got it, but just we need to arrange them. So take all this term to other side or multiply through it with negative sign. In either case you will get this sine square theta become plus, this become minus 15 sine theta, and plus 4 become minus 4 equal to 0, which is a required proof, hence proved. I hope it is very much clear to you all. Let's proceed for the second part of the same question. Okay, here it goes. Yes. Here, guys, after proving the first part, again, it's the second part is 3 marks. We have to solve this within the limits that it is the domain of the theta is lying between 0 degree till 360 degree. It means all 4 quadrants it's going to be covered. So let's start from the part 1. From 1, we have proved this whole expression as that was 4 sine square theta minus 15 sine theta minus 4 equal to 0. Here we need to find the values of the angle to solve this. So as regarding to sine theta, it's a quadratic equation, so we can apply the quadratic formula here, or we can make the factors or anything. So 4 times 4 16, I'm going to apply the midterm break rule. Theta minus 16 sine theta plus 1 sine theta minus 4 equal to 0. So from here, if you take 4 sine theta common, you will get sine theta minus 4 here plus 1, again sine theta minus 4, you get this one. So furthermore, simplification will give me the factor of this. So these are the factors or roots of this equation. Now we need to solve them. We need to solve it like once we will put sine theta is equal to 4, right? So you know the range of sine function is -1 to 1, so you will ignore this because it's bigger than that thing, so ignore it. And if you can use the calculator, you will not get the right answer with sine inverse of theta. So other thing is 4 sine theta is equal to -1 once you equate this to 0, right? So sine theta is -1 by 4. So theta will give you, here it is less than 0, right? Negative sine inverse of -1 by 4. And you should know in which quadrant, in which quadrant sine can be negative. Sine can be negative because you have the domain from 0 till 360, it is given. So sine function, sine is here positive, here it will be negative, like the same. It is cos is positive here, it is cos is negative, so you better can justify where it should be negative. It can either fall here, your angle, you can find this thing in the third quadrant, or it can be here, you can find this whole angle. This gives you 360 minus theta, whatever you will get from here, and this will give you, the second one will give you here it will be 180 plus theta, as we have well defined all these how to get these values. So from here, use the calculator, you'll get theta in term of it will be 14. We can take this as only this sign negative indicate in which quadrant your angle must lie. So here, if you will not put the negative sign, you will get 14.5 because here it will reflect the quadrant. Okay, theta goes to be 14.5. So final answer, theta can be 1, it can be in third quadrant 180 plus 14.5, and that gives you answer is 194.5 once you add it. And in the fourth quadrant, it will be theta will be 360 minus 14.5. That will give you on calculation 345.5 degree. So these are the two results for the given equation. I hope it is clear. Let's proceed for the next question. Yeah, guys, it is so simple. Here you are given the equation of the curve, that is y equal to 8 by x plus 2x, or you can rewrite it as 8x raised to power minus 1 plus 2x, and you are interested to find dy by dx first derivative and d2y by d of x for the second derivative as well. So your first derivative, as per rule you are well aware, power will multiply with the coefficient and make one less from the power and differential function, that is x, so it will be 1 plus here so power 1, so 2 x power 0, so x anything power 0 is 1. So we'll get dy by d of x equal to minus 8 x raised to power minus 2 plus 2, or you can rewrite it as minus 8 over x square plus 2. Both cases are same. Now we are going to find the second derivative. To find again differentiate with this with respect to x. So we'll get d2y by d of x square as, so take this, okay, let me change the color, this one. So what comes? Again, power will multiply the coefficient, becomes 16, make 1 less from the power, and differential of x is 1. And here, you know, the differentiate of this constant 2 is 0. So you can finish your answer d2y by d of x square as 16 x power minus 3, or you can add 16 over x power 3. This be the final result. I hope it is clear as. Okay, let's proceed for the second part of the same question. Here it goes. Here you are going to find the coordinates of the stationary points and state whether a reason the nature of the stationary points. Okay, here for the stationary point you all are well aware, we first find dy by dx and equal to 0, as this is the consequence of the part 1. So in the part 1 we already have find it the first derivative, and we need to equate that 0. So first derivative what we have find it, that was minus 8 over x square plus 2, that should be 0. Okay, remove the square as we done in the trigonometry proof. So each term multiplied by x square, we get minus 8 plus 2x square will equal to 0. So further solution will give you 2x square is equal to plus 8. So divided by 2 will give you 4, and taking square root will get plus and minus 2. While marking the paper, I found most of the students did well, but few students, instead of plus putting plus minus, they just put plus 2. Okay, so you are going to find the values, so and the nature of stationary points. So you guys need to put plus and minus, both cases. Square root will give you both answers, plus and minus, as I told you in the exam, in the class as well. Right, guys. So now we have this one, and the original function was you are given it was given whose differentiate was this. Y was given to be what it was. Let me check. That is, yes, 8 over x plus 2x. So in order to get the stationary point, that we need to complete x and y as well. So when here, when x is equal to plus 2, y will give you 8 by 2 plus 2 times 2, that will give 4 plus 4, that is 8. So your first stationary point goes to be 2 and 8. Similarly, when you replace x with minus 2, so let's see, 8 by minus 2 plus 2 times minus 2 minus 4 and minus 4 will give you minus 8. So other point goes to be, these are the two stationary points. So far we have done here. Now we need to find the nature of the stationary points. And you are well aware about the nature, how to find the nature. We will just, what we have done in the part 2, d2y by d of x square, that was 16 by x power 3. Here you just need to replace these two stationary points one by one and to decide the nature according to the specific rule what we have done in class. Let's see. At the first stationary point 2 and 8, you will see, do replace x with 2. It will be 16 by 2 square. We'll get 2, that is positive, bigger than 0. So it means the nature is what? Minimum. And similarly, at 2 minus 2 and minus 8, the second point, you will see d2y by d of x square. By replacing x with minus 2, you will get minus 2 minus 2, because 16 by minus 8 is minus 2, and that is less than 0. So it will give you the nature is maximum. And this is the final answer. I hope you all understood it. Let's proceed for the next question. Yes, guys, here the question comes. It is given a curve has equation this one, and a line has this. A is a constant. Show that the x coordinate of the points of intersection of the line and the curve are given by, this is 1 marks question. So it's so simple. So what to do? Just point of intersection, we need to equate these two lines. Any curve and line should be equated to get the intersecting point. We get x square minus x plus 3 equal to 3x plus a. So bring all here to make this expression. So we get x square minus x minus 3x plus 3 minus a equal to 0. So reshape in the desired form. So proved. So this was what we have to express our result. I hope it's clear. Now for the next case, part 2 of the same question 6, it is given is 2 marks question. Now for the case where the line intersects the curve at 2 points, yani if you have curve, so where the line intersects at 2 points, 1 point, 2 points, it is given that the x coordinates of the one of the point is -1. So x coordinate is already -1 here. Say it is -1 here, and we are looking for the other point of x coordinates, right? Okay, so here we know from the part 1 we have proved the intersection of the curve and the line in this form, that was equal to 0. So one root is given to you, so replace that, x is equal to -1 because it is given here. So -1 square minus 4 times -1 plus 3 minus a equal to 0. So 1 plus 4 plus 3 minus a equal to 0. So a goes to be 8. So now replace here the value of a, x square minus 4x plus 3 minus 8 will give you, okay, let me write. So we get x square minus 4x minus 5 equal to 0. Now you can apply a factor rule, completing square rule, or use a quadratic formula, anyone which is convenient for you and is applicable for the given question. So you can make the factor. I make the factor. I made it x minus 1 and x minus 5 will give you, the multiple will give you this equation back. So here x plus 1 equal to 0, one root is minus 1, as already it was given, this was given. So we are looking for the second other point of intersection, that was x minus 5 equal to 0. So x will equal to 5. This is the answer what we are looking for, the other root. I hope it is clear. Let's proceed for the third part of the same question. This is 4 mark question. It is given that for the case where the line is tangent to the curve at point P, it means if you have curve and tangent point, it can be any direction, right? Here, but it must pass the curve at single point, that's the tangent point. This is curve and this is tangent. Find the value of A and the coordinates of this point P. Okay, let's see. We are given from the part 1, from 1, x square minus 4x plus 3 minus a equal to 0. So we know when the tangent and the curve intersect, then we have b square minus 4ac equal to 0. That means discriminant must be 0. So applying p square minus 4ac, that will give you minus 4 square minus 4 times a times 3 minus a, and put it 0. 16 minus 12 plus 4a equal to 0. So 4a will give you minus 4 and a is given minus 1. So I got a minus 1. Now replace here. We get x square minus 4x plus 3 minus into minus 1 equal to 0. X square minus 4x plus 4 equal to 0. So by completing square by factors or formula, it will given me, I know this one. So repeated root, x minus 2 equal to 0. So x equal to 2. I got this one value and this is repeated value. So do replace this 2 to get this point P. Now replace the y coordinate, this x coordinates in any one here in the curve or the line. So given that equation of line as that was y equal to 3x and plus a, right? So here a already we got minus 1, so we can say y equal to 3x minus 1. So now replace x with 2, so we get y equal to, at x equals to 2, y equal to 3 times 2 minus 1, y is 5. So the required coordinate of P are 2, 5. And this be the final answer for the question number 6. I hope it is clear. Okay, let's proceed for the next question. Yes, guys, this is a question where I found most of the students stop thinking. I don't know why. Because if you comprehend it clearly, it seemed to be easy. Let's see how. Sorry. The first part was very easy, 1 mark question. The diagram shows a circle. This is from the circle Ramiya. Okay. The diagram shows a circle with center A and a radius R. This is small circle. The diameters CAD and BAE are perpendicular to each other. They are perpendicular, right perpendicular is given. A large circle has center B and passes through C and D. Show that the radius of the large circle is R square root 2. So, you know, center of the large circle here, so it must be this. We need to prove that it should be R square root 2. So when we can take this out, this triangle, like C A B, and we know AB's are CB's are as well, because these are two the radius of the small circle. So by using Pythagoras theorem, we can find this BC. BC is the radius of the capital one, that gives me the square root of, by using Pythagoras theorem. So R equal to 2 square R square. So it means square root 2 R root. We were looking for this. This is the radius of the larger circle. I hope it is clear so far, right? Okay, I'm going to remove this line because I need further description. Okay, now the second part is of 6 marks. Find the area of the shaded region in term of R, small r. It means talking about a small circle. Area of shaded region. If you can see the shaded region, area of shaded region, that is equal to area of this semicircle. If you can see my working on the figure, area of this semicircle, I can write area of semicircle, that is CED minus if I can minus this one, this portion, this is segment, so I can write minus sorry, let me select the pen, minus area of segment. What's name segment? CAD, I can say segment. So make it point P here, I can say CPD. So if I can found the area of the segment CPD, then it's very easy for me to subtract it from this semicircle, smaller semicircle. So let's see how to find CPD, right? I hope it is clear. Let me draw the circle for you again here to give you the complete description. Okay, done. Yes guys, I drew the small circle with center A, and this was the diameter, this is A, and here this was C, D, and okay, fine, and this was a line joining BA. Okay, so you can see guys, if I join this to make triangle, if I join this, because this is as well the diameter, so the right perpendicular here understood angle is in, because circular measure, so we'll write in radian. We prefer to write in radian measure, so it will pi by 4 angle here, pi by 4 angle here. If you are confused how to get pi by 4, you can apply here in part 1, the figure I drew separately. Apply this sine Say angle theta sine theta or tan theta, right? Or here tan theta is equal to what? Saukoto, any opposite AC over adjacent AB, that is R, that will give you 1. So theta will be tan inverse of 1. By using calculator, you will find it in a radian mode, it will be pi by 4. So it means if this is pi by 4, it's a diameter as well. So again, perpendicular bisector, so it is pi by 4. So total angle will give you pi by 2, right? Okay, now I'm going to select the colors. Yes, 1 minute. Yes. So if I can find the area of this sector, this whole sector, that I'm going to give it with the yellow color, and minus it from 1 minute from the area of this triangle, only that segment area will left. Did you get it? Let me repeat it again. You know, here I'm going to draw it separately. So area of segment, what we are looking for here, CPD equal to area of sector. What sector? BC, here it was P, na? PD minus area of triangle, what? BCD. So we can get the area of sector. I hope this concept is clear to you both or you all. Okay, let's proceed how to find. So area of sector BCPD, that is, you know the formula, half r square theta. So what is r here? Yes, r is already we calculated. Let me write with the red here. That was square root 2 r. In the first part we done this, square root 2 r, right? So I will use this half r square theta. So half r square, that is square root 2 r square, and theta was pi by 4 plus pi by 4 as this whole angle minus area of triangle BCD. What is the area of a triangle BCD? Area of triangle BCD, you can say again, this is let me show you this working. This was pi by 4 plus pi by 4 will give you pi by 2, and this is root 2 r, again root 2 r. So in the, you know, in our O levels, we know that half AB sine theta will give you the area of this triangle, because it's a triangle, not a right angle triangle. So minus, you can say yep, what it will be, okay, 1 by 2 times square root 2 r, again times square root 2 r, and theta is pi by 2, na? Sine pi by 2, sine pi by 2, right? Here, let's see what comes. 1 by 2 times 2r square, it will be pi by 2, because pi by 4 plus pi 2 times pi by 4 will give you pi by 2, minus 1 by 2 times 2 times r square sine pi by 2 will give you z1, Okay, here I get pi r square by 2, because this 2 will be cancelled, minus this 2 cancelled, r square. This is the area of the segment what I have calculated. So now apply this all here in this rule what we have decided. So we'll get shaded required shaded. Let me write with the other color so that it should be clear. Required shaded area will be area of the semicircles, that is half pi r square minus area of segment we have calculated here, that is pi r square by 2 minus r square. Once you can see, you can open the bracket, the first two terms will cancel out and you will get r square. That is the answer in term of r. I hope it is clear to you all. Let's proceed for the next question. Question number 8. This is about the APGP geometric progression or arithmetic progression. So this is 4 mark question. Let's see what is going to be asked for this question. It's given the first term of a progression is 4x and the second term is x square. And in first term, for the case where the progression is, let's see, it is given the progression is arithmetic with a common difference is 12. Find the possible value of x. Okay, it's given. For AP arithmetic progression, the first term is 4x, that is a, and the second term as given in second term is a plus d, that is x square. Along with it, we are also given d is equal to 12, the common difference given. So we are looking for what value of, find the possible value of x. So while solving this 1 and 2, if you replace the 1 in 2, we get 4x plus d is equal to x square. So d is x square minus 4x. As d is 12 is given, so do replace here is with 12. We get x square minus 4x. So x square minus 4x minus 12 equal to 0 by applying the quadratic formula, factor, whatever easy for you. We will get the two values of x. X is 6 and x, the two roots are 6 and minus 2. So here we have done. And for after evaluating values of x, it's given and corresponding value of the third term. So therefore third term, first, what will be the first term after replacing these two values of x in 1? Any from 1 we have a is equal to 4x. So a will give you 4 times 6, that is 24, or at minus 2, 4 times minus 2 will give you minus 8. We have two values of a, so similarly we will get two values of the third term because given values of third term. So third term for AP, we know third term is a plus 2d. So by replacing this a, d remains 12. So a3 is when it is 24 and d 12. 12 to the 24 and 24 will give you 48. So the third term can be this, or when you replace a with minus 8 and d the 12 as it is, so third term will be 24 and 8 it will be give you 16. So this will be the answer for the first part of question number 8. I hope it is clear. Let's proceed for the next. Okay, here it's given for the case where the progression is geometric. Now the sum of infinity is 8. Now it is given for GP. We know for the GP, the first term is A, that is given to be 4x, and the second term is AR, that is and the okay, and the infinity, and find the third term. We are looking for the third term, right? Second term is AR, that is given to be x square. So what will be the ratio R? You can divide here 1 and 2 by 1, so x square by 4x, a cancelled, so R will be x by 4 in term of x. So here what to do, is given sum to infinity. What is the rule for sum to infinity of GP? That is A over 1 minus R, when R is smaller than 1. Here R is this, so, and it's the sum is infinity. So S infinity will be A is what, 4x, 1 minus R is x by 4, and this gives you 8. So after simplifying this, 4 goes up, 4 for the 16, x over 4 minus x. Now do the cross multiplication. We get 32 minus 8x is equal to 16x. It comes here, 24x equal to 32. So divided by 24, x will be 32 by 24. 8 4s are 8 3s are. So x is what? 4 by 3. So similarly, you can replace in 3 to get r, implies that r will be 4 by 3 divided by 4. 4 goes, after simplifying you will get r is 1 by 3. So r is 1 by 3, and what we are looking for, the third term of GP. Third term of GP is AR power 2. So what to do, A is, yeah, we also need A as well. So after placing x, 4 by here in A is equal to 4 into 4 by 3, that gives 16 by 3. So A is 16 by 3 and R is 1 by 3 square. I will get 16 by 3 times 9, 16 by 27. This is the final answer for the part 2 of question number 8. Let's proceed for the question number 9. This video is more than it's 50 minutes almost. So here guys, question number 9. Express this in the form. This is a simple case of converting square. You guys are well aware about. First, do write the expression minus x square plus 6x minus 5. We need to reshape in this form. So first take minus 1 common for the first two terms. We get x square minus 6x minus 5. So half of this is 3. You are well aware about the rules, so I'm going to solve it. 3 square minus 3 square minus 5. The first three terms can be written as a perfect square, like x minus 3 whole square minus 9 minus 5. So minus into x minus 3 whole square plus 9 minus and minus plus 9 minus 5. So this is the final 3 marks result for this question number 9 part 1. Here A is what? Minus 1, B is what? Minus 3, and C is what? 4. I hope it is clear. Let's proceed for the next. Okay, it's 1 mark question, simple question. That is the function is this, again the part of the one consideration that m is 3. We know that function of x, already we have done this. Minus 1 x minus 3 whole square plus 4. Sorry. State the smallest value of m. Smallest value of m for which it is 1 function. So from here you can see, if you equate this x minus 3 equal to 0, because x is equal to m or bigger than m, so x goes to be 3. So I can say my m is what? 3. The smallest value of m is 3. So proceed for the next. It is given for the case where m is 5. Sorry, here it goes. case where m is 5, find an expression of f inverse and state the domain of f inverse. Simple is this. Your original function was f of x was minus x square plus 6x minus 5, right? So, and we sorted this in the computing square form in the first part in this form. We reshaped this, and now as you know, a function of f of x is equal to y, so make x as vector formula here. So we get x minus 3 whole square is equal to 4 minus y. So x minus 3 is equal to plus minus root 4 minus y. So x will be 3 plus minus 4 minus y square root. Yes, here you can see we also have to find it's given that in case m is 5, the expression this one, and state the domain of f inverse. So if you go with the shape of this one, generally if you can draw the shape, you can have this shape as well, right? So this is x-axis, this is y-axis. So what to do with the same function for the domain of f, uh, domain, the function, because a is negative here, so that's why it is concave down. So we can say here, first finish it, f inverse of x, f inverse of x will be, is concave down, so we let 3 plus root 4 minus x. This will be the final answer of the inverse function. And for the domain of f inverse, you know that is equal to range of f. And the origin function, as you know well, it was given f of x was minus x minus 3 whole square plus 4. So given m is 5, even if you replace x with 5, so what to do? It will be minus 5 minus 3 square plus 4 minus 4 plus 4, that will be 0. So it means the range will be here. It should be less than equal to 0. So I can say my domain of f inverse will be x is less than equal to 0. So this, because, and this is the final answer for the part 3 of the question number 9. Okay, let's proceed. Sorry, I made this line. Yes, proceed for the final question number. Sorry, it's not the final, it's question number 10. Okay guys, it's given a circle with the center this. Okay, very simple question for 3 marks. For this, x minus 8 whole square plus y minus 4 whole square is equal to 100. So by comparing this with the standard general form of equivalent circle with center AB and radius R, so we can say the center goes to be 8 and 4 and R is 10. We have to prove that that point T minus 6 and 6 is outside the circle. So we can get if a circle here with the centers 8 4 and its radius is what, 10, and T is somewhere, say suppose it is here, T, and if we need to find the distance between C and T, if it is bigger than 10, then it will be outside. If it is equal to 10, that is on the circle. If it is less than 10, it will be inside the circle, as the rule says. So let's find CT, the distance. So 8 plus 6 square, 4 minus 6 square, 196 plus 4, that gives me 200 square root, that is more than 10 root 2. Yeah, okay. Which is bigger than R. Hence, T lies outside the circle. Proved. We have to prove this thing. Okay. Next part of the same question is 2 marks. The two tangents from T to the circle are drawn. Show that the angle between one of the tangent is 45. It means T is somewhere outside. This is the radius. And suppose we have a tangent one here like this and other one like this. Okay, T is here. So this is the radius, this 10, this 10, and we know two tangents drawn, they are equal and they are equal distance from the center point of intersection of the tangent as per the property, and this makes the right angle here. This is right angle. Tangent always makes the right angle with the radius of the circle. The property was much too much clear to you guys. So by using the relation, we know this CT already. We got this that was 10 square root. Yeah, and this is 10. So we need to find this angle between the tangent and the tangents and this. So we can find this angle theta here, or this the same one. Okay, so by using this figure, let me draw it separately so you can guys you can see it. T C right angle, this was 10 root 2, this was 10, and theta, we can apply base and opposite hypotenuse. So co adjacent cos theta is this over 10 root 2. Theta will give you cos inverse of 1 over root 2. So it's in degree. So by changing the mode of calculator in degree here, so we'll get 45 degree and proved. I hope it is clear, right? Let's proceed for the next part. It's a 4 marks question. The two tangents touch the circle at A and B. Okay, the same thing. Like, let me draw it. Okay, let me draw this very. Okay, one tangent was here, other was here. A and B. Find the equation of the line AB. We are going to find this line. This is center. This is line AB, and we know this tangent T. This is C. These 2 points we know, and this what 6 and no 8 and 4. So guys, with the critical analysis of this figure, you can see what we have done uh, in the first part. If you can see, if we can find this point, this say is P point. If you can find this one, this P point, right, then we can find the equation of tangent as well, because this is perpendicular to the CT. So gradient is easily to find out. We can find the gradient of CT. That is, you know well, 6 minus 4 over change of y to change of x. That will give me 1 by 7 minus. So gradient of AB, as it is perpendicular to CT, so negative reciprocal of it becomes plus 7, because we know perpendicular cases the multiple of the two lines must be -1. So now if we can find this point P, and here you can see this was 10, this was 10 as well, this was what with the T, this was 10 root 2. If you can join this one and this one, so we can find this by applying you know what, the Pythagoras theorem. You will find this 10 as well, you can find this 10 as well by using Pythagoras theorem for the both cases, right? So it means it's seem to be a square or a rhombus. So this point P will be the midpoint. midpoint of CT, and that gives me 8 minus 6 by 2 and 4 plus 6 by 2, and that should be 2 by 1 and 5. So therefore equation of line AB at M7 passing through point P, that is 1 5, is y equal to mx plus c, or y minus, I don't know, it is y mx plus c, so I will go with the same. So y equal to 7x plus c. So at this 5 is equal to 7 plus c, c gives me minus 2. So my line AB is y equal to 7x minus 2. This be the line. I hope it's clear. Now hurry up for the next x coordinates of A and B. So x coordinates of A and B very easy. Just you can, because they are going to touch the circle, so replace this in the equation of circle, that was x minus 8 whole square plus y minus 2 minus 4 whole square equal to 100. So replace this y with the line x minus 8 whole square plus 7x minus 2 minus 4 whole square is equal to 100. So x minus 8 whole square plus 7x minus 6 whole square equal to 100. Expanding it, we'll get the results in term of A, that will be 0 and minus 2, and B will be 2 and 12. You can simplify to get these results, and I hope you guys can do this and it's easy to understand. Okay, let's proceed for the final part, final question. Question number 11. It's easy bonus question. The first question says, the part one of the question says, show that this is a shaded part we are given. Show that PQ is PQ. This is P and this is Q. Coordinates of P are 6 and 5. It's not clearly here. And this is the equation of a curve as given here. So we need to know that this is show that the point PQ is normal to the curve. So equation of curve is y equal to 1 plus 4x power 1 by 2, and it is passing at point 6 and 5. So we will find dy by dfx first. That, as you know, that it will be, finally I am going to write it directly because you know well about the rule. So at point 6 and 5, that will give me the gradient of the curve. Say it is m1, 2 times this is 1 plus 24, this is 25 power minus 1 by 2, that is 2 by 5. Now gradient of line PQ, this line P and Q. So that's supposed to be, say it's m2, the rate of change in y coordinates to x coordinates, that is minus 5 by 2. Since we can see m1 times m2 is equal to negative 1, so 5 by 2 times minus 5, 2 by 5, it's 2 by 5 times minus 5 by 2, that give you minus 1 equal to minus 1, hence proved. Okay, the final part of the question. Find, showing all necessary working, the exact volume of the revolution to obtain the volume of the revolution obtained when the shaded region. Okay, it's simple. Volume, we know volume of the curve, because in the figure you can see the all portion is shaded. The curve required volume, okay, let me get the space. Required volume will be equal to volume of curve plus volume of cone, because the line, once it start rotating, yeah, you can see I can sketch a rough curve here. It will be it was look like to be this. Here P, and it was the line Q. This was about x-axis, because it is going to rotate about 360 about x-axis. So if you draw this, because this was 6 and 5, so it means this is 5. So rotation goes down along x-axis here, and this will be here, and the curve, you can see this curve is and this will gives you the cone, the shape of the triangle will give you the shape of the cone when it start rotating. As in the previous video I have explained you well how to find the volume of the curve and the cone. So by applying the rule, v is equal to pi, because it's a definite integral, so its range from here till here it goes to be 6, then 8 for the triangle, the prism. So 0 to what, 0 to 6 y square d of x plus volume of cone. Volume of cone we know well, we can write it directly in, otherwise we can find, you know, the equation of line PQ, and then we can apply this in the formula to get other approach. But here is given volume, so volume of Q cone is 1 by 3 pi r square h, and what will be the r? That will be 5. So volume equal to pi and 0 to 6, and y square of the curve will give you 1 plus 4x raised to power square, will root will be eliminated, d of x plus 1 by 3 pi r is 5 square, and h from 6 to 8 it is 2. So simplify this, x plus 2x square 0 to 6 plus this goes to be what? Simplify this in the calculator, and we will get it 50 pi by 3, and this will be 78 pi plus 50 pi by 3, and finally you can write your answer 94 whole 2 by 3 pi, or 284 pi by 3. So this is the end of the whole paper. I hope you all understood it well, and in any query you can contact me again. Wish you good luck, guys. Keep working hard for the other past few papers so that you can get good grade for the CIs. Best of luck. Allah Hafiz.